So, what if I told you there was a hidden connection, a kind of secret resonance, linking the numbers that define circles, the numbers that define growth, and maybe even the universe itself? Today, we're diving into a really cool thought experiment that suggests there just might be a link between some of the most fundamental, famous numbers we know. And it all kicks off with one of the biggest questions you can possibly ask. I mean, think about it. If the potential for everything is infinite, totally chaotic, then how in the world do we end up right here, in a universe that has stable rules, predictable patterns, and reliable structures? How does any kind of order pop out of total disorder? The source material we're looking at today offers a way to think about this, and it's called the theory of infinity. The main idea is actually pretty simple, but it's really profound. It says that infinity isn't some number you're trying to reach. It's the raw, inexhaustible clay of existence. And the tool that carves a stable reality out of all that clay, well, that tool is symmetry. Okay, so if we're trying to find order in all that chaos, the first thing we've got to do is look for things that don't change, Things that stay constant even when everything else is going wild. We need to find some anchors of stability. And our very first clue comes from this little example called a Konrad Triple. Now, these anchors have a name. They're called invariants. The best way to think of them is as the unbreakable rules of a system. They're the things that hold true no matter how much you shake things up. And finding them is the very first sign of structure in a sea of pure randomness. So check this out. This is where we see symmetry perform a kind of magic trick. We start with this formula. And let's be honest, it looks pretty messy, right? A bunch of cubes and products, but watch what happens. We apply just one simple rule, one constraint. We say that A has to equal B plus C. The second you enforce that little bit of symmetry, the whole complicated formula just collapses. It distills right down to this super clean, simple, stable result. And that right there is the whole point in a nutshell. A single, elegant rule, a single symmetry can take something that looks totally chaotic and transform it into something predictable and stable. This is our first real building block for creating order. So that leads to a pretty cool question. If just one little rule can create that much stability, what would happen if we built an entire machine based on layers and layers of these rules? Well, that's the idea behind something that theory calls the Amanda engine. The Amanda engine is basically a thought experiment. You can imagine it's a kind of universe simulator, or maybe like a quality control machine for reality itself. Its job is to take a whole bunch of chaotic inputs and run them through a series of tests, a series of symmetry checks, just to see if a stable, self-contained little universe can pop out the other side. So how does this thing actually work? Well, it starts with a structure based on the Fibonacci sequence, which gives it a foundation for stable growth. Then it starts injecting random events onto a circle. But, and this is the really clever part, it doesn't just throw them on there randomly. It spaces them using the golden angle. That's a very specific angle that nature uses, like in sunflower seeds, to pack things in as efficiently as possible, with no weird gaps or clumps. Finally, it runs a bunch of audits on itself, checking to make sure the whole system is balanced and completely sealed off from the chaos outside. Okay, now this is where it gets really, really interesting, because when you build this theoretical machine and you let it run based on all these rules of symmetry, a number emerges. A very, very specific number. And it's a number that seems to be echoing something incredibly fundamental about the universe. Here it is. This is the formula for that number. It's called the golden angle Euler resonance invariant. Now, don't worry about trying to solve it. Just look at the ingredients we put in. You've got pi, the number that defines every circle. And you've got the golden ratio, phi, the number behind perfect proportions and efficient growth. These are the constants we chose to build our machine with. The question is, what number do they spit out? The results is this, 1.649063, and so on. At first glance, it's just a number. It looks like a random string of digits. And I know what you're probably thinking. Okay, it's just a number, so what? Who cares? Why on earth does this particular number, spit out by our little imaginary machine, matter at all? Well, this is why. Take a look at this table. Our number, that resonance invariant, is just shockingly close to two other absolute celebrity constants of math and physics. It's almost identical to the square root of e, which is the fundamental number of all natural continuous growth. and is also incredibly close to pi squared divided by 6, a famous value that pops up in number theory and quantum mechanics. I mean, these numbers come from completely different parts of mathematics. They should have nothing to do with each other. And yet here they are, practically the same value. This bar chart just makes it impossible to ignore. Look how close those bars are. The difference is absolutely tiny. It's what the source material calls a resonance. Almost like the rules of symmetry we built into our engine just happen to perfectly tune into a fundamental frequency of the entire mathematical universe. So, what does a resonance like this actually mean? Well, according to this theory, it's not a coincidence. It's a bridge. It's a massive clue about how our finite, ordered world connects all the way back to the infinite possibilities it came from. The theory breaks it down like this. The resonance is linked to the number E, represents chaos, that raw, explosive, exponential potential of the infinite. It's linked to the golden ratio phi, that represents form. That's the act of taking all that chaos and shaping it into beautiful, stable patterns. And finally, its connection to pi squared over 6, that represents closure. See, that value is the answer to a famous problem where you add up an infinite number of fractions and get a single finite answer. It's the perfect metaphor for how you can create a closed, stable system out of an endless process. As the source material puts it, and I think this is just beautiful, invariants serve as anchors. They tie a finite engine to the harmonies of the infinite. In other words, this special number isn't just a fluke, it's a tether. It's the proof that the simple rules we use to build our finite little world are perfectly in tune with the deep, fundamental harmonies of infinity itself. And that just leaves us with one final, absolutely fascinating question. If this one resonance exists, this incredible link between chaos, form, and closure, what other hidden connections, what other cosmic harmonies are just out there, waiting for us to find them?